Hello and welcome back, everyone. Today we're going into section 6.2 on trigonometric functions, and we're taking a unit circle approach to get us started. So the idea behind the unit circle, we are centered on the origin. Capo for origin, centered on 0, 0, and we have a radius of 1. So the idea here is, and again, you'll see why I'm not an art teacher. We'll pretend that's centered nice and neat on the origin. We have a radius of 1. This will be our angle theta here, radius of 1. This is our point. We'll call that arbitrarily xy. This guy is the origin. And we can always drop down a little right triangle there. So our 6 basic trig functions start with the cosine. Cosine of theta is x over 1. Sine of theta, y over 1. And you can simplify these, of course. And tangent theta is defined to be y over x, which is also sine theta divided by cosine theta. So really, sine and cosine are the meat of anything we're doing with trig. All 4 of the other ones are built out of doing things with sines and cosines. So the secant is just the reciprocal of the cosine. So instead of x, it's 1 over x. Cosecant, reciprocal of the sine. And cotangent, not super surprisingly, reciprocal of tangent. So those are just some definitions that we know. And we'll start with looking at a few special angles and kind of build from there. So we're going to measure theta 2 ways, in radians and a little reminder of what it would mean in degrees. And then we'll talk about sine, cosine, tangent, cosecant, secant, and cotangent. So we'll start with 0 radians, which is also 0 degrees. So sketching our unit circle here, an angle of 0 degrees, we're basically just sitting with a line segment right on the axis. So this is sitting at, since we're on the unit circle, 1, 0. So the sine is defined to be y, so that's 0. Cosine is x, that's a 1. Tangent is sine divided by cosine. 0 divided by 1 is still 0. Cosecant is the reciprocal of the sine, which is undefined. 0 does not have a reciprocal. 1 is its own reciprocal, and again 0 has no reciprocal, so we are undefined. So next we'll take a look at pi over 2 radians. Remember, pi was equal to 180 degrees, so pi over 2 is half of that, so we're talking about a 90-degree angle here. Again, I'll make one of my famous rough sketches. So now we're up here. Remember, the initial angle is going to be along the positive x-axis. So 90 degrees. Here's what we're talking. So here is our point, and our point then is at 0 for the x, 1 for the y. So our sine is 1, cosine is 0, tangent 1 divided by 0 is undefined, and then our reciprocals. 1 is its own reciprocal, 0 does not have a reciprocal. Cotangent, remember that is x over y. 0 divided by 1 is still a 0. All right, so next up we'll look at pi. Pi, remember that is 180 degrees. So we are back here at -1 for x, 0 for the y. So sine is back to 0, y coordinate 0, x coordinate -1. 0 divided by -1 is still 0. Reciprocal of 0 is undefined. Reciprocal of -1 is still a -1. And reciprocal of 0 is, as usual, undefined. 3 pi over 2. That is 270 degrees. And if you use your Rosetta Stone of pi is 180 degrees, and just multiply the 3 pi over 2 by 180 over pi, you'll get your 270 there. So where is that? Well, that is 3/4 of the way around, so now we're down here at 0 for the x, -1 for the y. So our sine is -1, cosine is 0, tangent, -1 divided by 0 is undefined. Cosecant, reciprocal of -1 is -1. 0 does not have a reciprocal. And cotangent, x over y, 0 divided by -1 is 0. After that, we would be all the way up to 2 pi, but that takes us around to where we started with at the 0-degree one. So those are the 6 trig functions just at the basically the 4 compass points on the unit circle. So then next we look at, well, what if we go around a little bit more than that? So let's say I want the sine of 7 pi. Well, remember, pi is halfway around, so here is 1 pi. Back around to the beginning, now we're at 2 pi. Back around here, now we're at 3 pi. Back around again, 4 pi. 5 pi, 6 pi, 7 pi takes us back here. So the coordinates of that on the unit circle, -1 and 0. Sine is the y coordinate, so sine of 7 pi is 0. Similarly, we could do sine of, say, 11 pi over 2. So remember, pi over 2 is a quarter turn. So here's 1 pi over 2, 2 pi over 2, or just pi, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2, 11 pi over 2. And that is what they were asking us about. And the sign is the y-coordinate. Well, down here on the unit circle, we're at 0, -1. Our y-coordinate is a -1. One more of these, and then we'll start looking at some other special angles. We'll look at the cosine of -9 pi. I would recommend seeing if you can try it out. So pause the video, see what you can work out, see if you can figure out what this should be without a calculator, just drawing your circle. Pause it and we'll come back. Okay, welcome back. So here's our beautiful unit circle. Ooh, that one is even more lumpy than my usual unit circles. All right, so remember, pi is a half of a turn around in the circle. This is just heading in the negative direction. So here's -1 pi, -2 pi, -3 pi, -4 pi, -5 pi, -6 pi, -7 pi, -8 pi, -9 pi. And we are at the -1, 0 point on there. Cosine, remember, is the x-coordinate on the unit circle, so this is worth -1. All right. So next up, we're going to look at the exact values of the 6 basic trig functions for a value of pi over 4. So remember, pi is 180 degrees, pi over 2 is 90, pi over 4 then would be 45 degrees. So again, we're going to assume we're on the unit circle, so centered on the origin, radius of 1. And our angle is raised at 45 degrees. So here's our point X, Y. And we're going to drop a little perpendicular line down from there, a 90-degree angle. Now, as you know, 180 degrees total inside of a triangle. There's our 90. We have 90 more degrees to go. 45 is here. 45 has to be there as well. So sort of zooming in on what we have. So here's our pi over 4, or 45 degrees. Here's our other pi over 4, or 45 degrees. Here's our 90. So we have an isosceles triangle, which means the two legs are equivalent. Well, from here to here, since we dropped our perpendicular straight down, it has to be x in length, so this guy is also x in length. And we have a radius. Since we're on the unit circle, this has to be a 1. So by the Pythagorean theorem, the Egyptians had that figured out before Pythagoras, but he's the one that happened to put the name on it. His name stuck to it. Anyway, x squared, leg squared, plus x squared. Leg squared again is hypotenuse squared. So 2x squared is worth 1. X squared is a half. So x is, usually we would include a plus or minus, but we're talking a distance. So square root of a half. And we'll go ahead and rationalize that denominator as well. So x is root 2 over 2. Notice our y is also then root 2 over 2 because the legs are the same length. So our sine of theta at 45 degrees would be root 2 over 2. Cosine of pi over 4 is also root 2 over 2. Tangent of pi over 4 is x over y, or sine over cosine. Either way, we're dividing something by itself. 1 is our result. And then their partners. Cosecant of pi over 4 is the reciprocal of 2 over root 2. Or, I'm sorry, the reciprocal of root 2 over 2, which would be 2 over root 2. And we can go ahead and rationalize that and do a little reducing. So that's 2 root 2 over 2, or simply root 2. The secant of pi over 4, that's the partner to cosine, reciprocal of cosine, which is also then going to be root 2. And the cotangent of pi over 4, again, is going to be 1. It's our x over y instead of y over x, but either way, in this case, we get a nice, neat, pretty 1 out of that. So that's one of our special angles. Next, we'll look at some exact values for pi over 6. So just take a quick second to pause and review and see if you can put pi over 6 into degrees. Okay, welcome back. So hopefully you figured out that that is a nice, neat, pretty 30-degree angle. All right. It's a nice, neat, pretty 30-degree angle. So here is our unit circle. And we have a 30-degree angle here. Again, I'm going to drop a perpendicular here, which makes this guy a 60-degree angle. With my drawings, you're definitely going to want to trust my numbers, not my ability to freehand sketch these angles to scale. Just a little heads up there. So one thing you might notice, again, here's our xy. We have a radius of 1. You might notice that if I draw another 30-degree angle off of this and extend this, so here's another 30-degree angle. This is still a right angle here. This guy also has to be then a 60-degree angle. And if we put the two together, what we've made is, and again, definitely not to scale, we've made an equilateral triangle, 60 degrees, 60 degrees, 60 degrees. So all three of those sides are the same. Well, since we're on the unit circle, this guy's a 1, this guy's a 1, these two put together are 1, so that means this fellow is 1/2. So filling in what we know in a little more cleaned up drawing. Here's the 1, here's the 1/2. Our point here was xy, so this is x in size. Pythagoras tells us then that x squared plus a half squared is 1 squared. So x squared plus a quarter is 1, so x squared is 3/4. So x is √3 over √4, or √3 over 2. You can see from here our y is 1/2. And that gives us all the ammo we need to fill in our 6 basic functions. So the sine of pi over 6, again, 30 degrees. Sine is the y over 1, half over 1 is half. Cosine of pi over 6, x over 1 are just x. Tangent of pi over 6 is defined as y over x or sine over cosine. Pi over 6 is our root 3 over 2. My apologies for the little brain freeze there. Cosine, our x was the same as root 3 over 2. Tangent, y over our x value. So half over root 3 over 2. So that's a half times 2 over root 3. 1 over root 3, so the 2's drop. And go ahead and rationalize. So root 3 over 3. So our 3 partners on that. Reciprocal of sine is the cosecant. And the reciprocal of a half is 2. Reciprocal of cosine is secant. So the secant of pi over 6 would be the reciprocal of root 3 over 2, which would be 2 over root 3. And again, we can rationalize that. So 2 root 3 over 3. And the reciprocal of tangent, cotangent. So instead of the y over x, it's x over y. So root 3 over 2 over a half, which is root 3 over 2 times 2 over 1. The 2's drop, and we just have a nice, neat, pretty root 3 there. Alright, so the next one we'll look at, last of our sort of special angles, would be theta equals pi over 3. So take a moment, turn that into degrees. I'll just let you pause it and replay it. Okay, welcome back. So theta, hopefully you figured out that was 60 degrees. Using your Rosetta Stone, that pi is 180 degrees. So just multiplying the pi over 3 by 180 over pi. 180 over 3 is the 60. So one thing you might notice on that is that forms a triangle that we've already worked with. It's just in a different spot. So our last triangle was a 30, 60, 90 triangle with the 30 down here. Well, now the 60 is down here. So the hypotenuse is still worth 1, but instead of this vertical piece being half, this bottom piece is the half, since that's opposite the 30, opposite the 60. Recall we had root 3 over 2. So see if you can fill out the function, the 6 trig function values for that. So see if you can find sine of pi over 3, cosine of pi over 3, tangent of pi over 3, and their reciprocals. Okay, so go ahead and pause it, see if you can complete that. Okay, welcome back. So sine on a unit circle is the y value, so that is root 3 over 2. Cosine is the x value, that is 1/2, and tangent is sine over cosine, √3/2 divided by 1/2. Divided by 1/2 is same as multiplying by 2/1, so √3. Cosecant, reciprocal of √3/2, 2/3, and rationalize. So 2√3/3. Reciprocal of 1/2 is 2. Reciprocal of √3, 1/√3, which is √3/3. So a lot of the other work that we do involves just using multiples of these special angles. So the special ones are called pi/4, pi/3, pi/6. Basically on that, just count them out on your unit circle and just use the quadrants to figure out sign changes. So for example, if we look at theta is 3 pi/4. So pi/4, remember, was a 45-degree angle. So here's 1 pi/4, 2 pi/4, 3 pi/4. We're here in quadrant 2. So if that's where my triangle is, my x-coordinate, notice, is a negative. My y-coordinate is a positive. It will have all the same properties as the pi/4 did. We're just figuring out sign changes. So this is still a 45, 45, 90 triangle. Still has a hypotenuse of 1. So each of these sides is √2/2. So that means our sine of 3 pi/4, the y value is √2/2. Cosine of 3 pi/4 in absolute value is √2/2, but don't forget we're in quadrant 2, so it is negative √2/2. Tangent of 3 pi/4, x over y, or I'm sorry, y over x, or sine over cosine, whichever way you want to think of it. And a positive over a negative is a negative, and same absolute value, so they get a 1. So -1 would be our tangent. And then they're buddies. So the cosecant of 3 pi/4 is just the reciprocal of √2/2, which is 2/√2. And rationalize and reduce. So 2√2/2, which is just √2. The secant of 3 pi/4, reciprocal of the cosine, so that would just be a negative √2. So just don't forget to bring your sign along. And the cotangent of 3 pi/4, also just a -1. Same absolute value, opposite side signs. Notice that's a -1 is also its own reciprocal. Alright, so we'll do another special another multiple of one of our specials. So we'll do theta is 5 pi/3. So recall, pi/3 was 60 degrees. So 2 clicks here is 60 degrees, or pi/3. 1, 2 more, there's 2 pi over 3. 1, 2 more, 3 pi over 3, which notice that does fit with pi being 180 degrees. 3 pi over 3, which is the same as pi. 60 more, so 2 more clicks. So that is 4 pi over 3, 2 more, and we're down here. And this is 5 pi over 3. And if we added 1 more pi over 3 to that, we'd be at 6 pi over 3, which is 2 pi, which is also the 0. So this is basically a 60-degree angle down here. And there's our 90. So think negative 60 degrees. So as far as sine work, our x is now positive, our y is now the negative. Hypotenuse on the unit circle is always a 1. So this is at 1/2 for the x, and root 3 over 2 for the y, and since we're down here, we'll call it a negative. So the xy coordinates of that point on the unit circle, half negative root 3 over 2, and that's all we need to make our 6 functions. In fact, why don't you pause the video again, see if you can make the 6 functions. Okay, welcome back. So sine of 5 pi over 3 on the unit circle, that is the y coordinate, so that is negative root 3 over 2. Cosine 5 pi over 3, x coordinate is 1/2. Tangent of 5 pi over 3, sine over cosine, negative root 3 over 2 divided by 1/2 is the same as times 2, so negative root 3. Cosecant 5 pi over 3, 2 over negative root 3, and rationalize. So that would be still negative, and then 2 root 3 over 3. Secant of 5 pi over 3, reciprocal of 1/2 is 2, and cotangent 5 pi over 3, reciprocal of the tangent, so 1 over negative root 3, and rationalize. So negative root 3 over 3.